Hi everyone, my name is Jian. I'm a PhD student at Indiana University. Today I'm going to talk about my work Tweezers, a framework for security event detection via event attribution-centric tweet embedding. So this work was done in collaboration with my advisor, Professor Xiaojing Liao, and amazing colleagues from the KAIST and the S2W. So social media has been widely recognized as an important source of threat intelligence. So as highlighted by the Trend Micro, which is one of the famous security companies, mentioned that social media is a viable source of threat intelligence. Also, similar Recorded Future also mentions that the social media platforms are a treasure trove of information that give early warnings on emerging threats. So why the social media is an important source of threat intelligence? So social media is a platform where people come to share the latest informations like daily tweets, etc. But security professionals and practitioners are also come to these platforms to share the latest informations, including the security event. So then why the security event are important? So security event actually can provide an actionable threat intelligence. So for example, the first event, which is related to OpenSSL vulnerability, which comes with the CVEs, which can be used for identify and patch the vulnerabilities. And the second, proxy-bot related event, which have the IPs and hashes, which can be used for the detection purpose. And the last, the phishing campaign event, which comes with the phishing URLs, which can prevent individuals to falling victim to such campaigns. So as such, security event per se is an actionable threat intelligence. So however, detecting the security event from Twitter introduces two unique challenges. So first one is the overwhelming volume of tweets. As we all know that there are a lot of tweets emerge every day, and a lot of noises and irrelevant content also comes along. So extract the necessary security event from this large volume of tweets becomes very challenging. The second challenge is to ensure the complete coverage of the security event. So we want to detect a wide range of events, but we don't want to miss any critical events. But we find that existing method only cover 3 to 30% of the security events, miss many critical security incidents. So there have been many efforts been made to automatically extract the security event from the Twitter. So they always approach this problem as a two-step method. So they first leverage a text embedding to embed tweets, such as word2vec and glove. And then they apply the clustering algorithms like the k-means and the db-scans. However, it introduces a lot of misidentification cases. And we find that this is also noted in some transformer-based methods, latest transformer-based models like the BERT and the llamas. So why does this happen? So in this study, we find that there is actually a 4 similarity issues in the text embeddings. So there are 3 different tweets. So pink dot represents tweets related to WhatsApp 0 days, and the blue dots represent tweets related to Microsoft Exchange 0 days. So what we found is that the distance between the tweets belong to the same event, which is the T1 and T prime E1 here, is actually larger than the distance between the tweets belong to the different event, which is the T1 and T2 in these pictures. So this is because like T1 and T2, which belong to different events, actually have very similar lexical and syntax patterns. And this makes the text embedding models to misunderstand them as a very similar tweets. So, but actually what can distinguish the events in this case is the WhatsApp 0 day and Microsoft Exchange, which is the different exploited vulnerability, which is also the one of the security attributes in this event. So different events usually have like different security attributes. For example, the first one usually have the observed data, and the second one have the murderers, and third one have threat actors. So a single security event might have like different security attributes, which is the key to distinguish different security events. So we try to leverage these security attributes, and we find that these security attributes are all actually well defined in the STIX objects, which is a structured language for describing, sharing, and analyzing the cyber threat intelligence consistently. It is also the de facto standard in the cyber threat intelligence, and it defines like 18 different objects, which in our paper we refer to as the security attributes, and use these information for security event detections. So now we know that security attributes are the key to distinguish different events. Then how to leverage this information for security event detection? So our solution is leveraging the graph representations. So in our papers, we propose a tree relation graph, which where the tweets with common security attributes are connected to each other. So this tweet relation graph contains the information on how security attributes are shared across tweets. So as can be seen in the figure, that three tweets are actually quite distinguishable because they share different neighbors. In other words, they share different security attributes to other tweets. So we try to leverage these graph informations. Then how to leverage these informations? So in our work, we propose to use a graph neural network. So we try to encode the information in the tweet relation graph into the embedding space by using the graph neural network. Specifically, we use the graph attention network version 2 to encode the informations. And for the optimization, we use the contrastive loss functions containing the triplet loss and the pairwise loss. So these two loss functions, what they essentially do is they're trying to make the tweets belong to the same event to close to each other, while the tweets belong to different events to far away from each other. So let me talk about the entire tweet embedding workflow. So first, there is the tweets. We extract the text and temporal informations and encode them into the vector space. So as I mentioned, that just using the text alone is not enough because they have like force similarity issues. So what we do is we extract the tweet security attributes from the tweets by leveraging a large language models. So extract these entities and we construct the graph based on these entities, as I mentioned earlier. So this tweet relation graph and the initial features will be served as an input of the graph neural network, and finally we will get the tweet embeddings. So to test the effectiveness of our approach, we test our method on our data sets, which is 167 security events spanning 2054 tweets. So we split the data sets into training, validation, and testings. And for the tests, we test distinct time periods because we want to test the robustness against the time shift. So we also compare our method with the text-based baselines and the pre-trained language model embedding methods. And we also compare our method with some basic graph-based baselines. And for the metrics, we use three standards for testing the effectiveness of the clustering algorithm, which is NMI, AMI, and ARI. So this is the result. So as can be seen in this figure, our method outperforms all the existing baselines, including the keyword-based embeddings and the pre-trained language model embeddings. So what we want to highlight here is that BirdTweet and the SecureBird, which is further trained on the Twitter and the security corpus. Even though they are domain specific, they can still not outperform our method because, as I mentioned, they did not fully capture the security attributes in their embeddings. And for the graph method, this method did not extract the security attributes and construct the graph. Instead, they extract the regular named entities from the Twitter. So, for example, the people, organization, etc., which is defined in the SPACY packages. They just extract these entities and construct the graph. So, which is not security attributes, which also cause lower performance compared to our methods. So in our work, we also propose a Tweezers, which is an end-to-end framework for security event detections, which takes a stream of tweet data as an input and output the event instances. So this framework contains three different steps. First, they will do the tweet filtering. So they first get the stream of tweet data and do the categorizations. And in these categorizations, those not related to the security category will be filtered out, and those only relate to the security will be retained and passed to the tweet embedding methods, which is proposed in our papers. And then these tweet embeddings will be going to the event identification phase, where we use the DB scans to identify the event instances. So there is more in the paper about this tweet category tagging. So for this tweet category tagging specifically, we introduced 7 categories to enhance the correctness and the effectiveness of the labeling and the tweet classification process. We also enable the multi-category classifications for accurate event categorizations. And for this framework, we also do the end-to-end evaluations compared to the baselines to test the effectiveness, and we find that it doubles the event detection coverage and the precision compared to the baselines. And in this paper, leveraging our framework, we also present 2 use cases. First, we try to analyze the security trends by using our framework. And the second use case is finding some informative security users who provide the insightful and detailed analysis of the security events. So to summarize, in this paper, we introduce a novel event attribution-centric tweet embedding for precise and comprehensive security event detections. We also develop an end-to-end framework for which outperforms baselines by doubling its event detection precision and coverage. And we also demonstrate two real-world use cases like the security trend analysis and the finding informative security users. So that's it for my presentation. So I'm happy to take any questions.
Okay, thank you for the great talk. So if you have questions, please come over here and or come behind, line behind that microphone. Please, this is a small community, and you should ask questions. Okay, if not, I'll kick off this Q&A session by asking you one question first. So, like we all are seeing right now, Twitter is gradually becoming a dumpster. So have you ever thought of applying your solution to other alternative platforms?
Oh yeah, that's a very good question. So in our paper, we actually test our framework into the mastodons, so which also shows very effective results because yeah, same thing goes to Mastodon because they also have such like for similarity issues, and we also trying to extract the security attributes which is effective for security event detections. So we tested and it's very effective as well. So you can check our paper for more details about these Mastodon platforms.
Other questions? No? Okay. A second question for you. So I understand that your approach is very specific to security, to detecting security events, right? But which part of your solution is specific to security? I think your solution is more specific to events. Does it extend to maybe safety or like other kind of events that are maybe beyond the security field? I'm just curious.
I think your question is about whether our approach is applicable to other domains or yeah.
Exactly.
Yeah, so I think the key here is that we want to detect security events and we use the security attributes, which is key to distinguish different events. But I think if you have like a specific event to detect and if you have specific event attributes that you think is more effective, I believe there is. And I think if we can just use same method as our approach, I think it is also applicable to other domains if they have like specific attributes that are important to distinguish different events.
Very cool. Did you attempt that?
Not yet.
Not yet? Awesome.
Yeah.
Maybe that can be future research.
Okay. Yeah, thank you.
Okay, no more questions. Let's thank the speaker.